Hi, Mr. Andrew here, and today we're dealing with rational equations. So again, rational just means that we're in some way dividing by an x, and then we, as a result, can have holes in vertical asymptotes. And that's what we're going to discuss today, holes in vertical asymptotes. Now here, as we look at this equation, the first thing we want to do is try and factor everything. So here, that x squared plus 9, that's a sum of squares. It's not a difference of squares. So normally we'd think something like that would factor, but because that's an addition sign between them, it does not. So I'm just going to leave it as is. And then underneath that, x squared minus x minus 6, I can factor that. I can say that is x minus 3, x plus 2. Okay? So now, because I have these down here, and they don't cancel off anything up there, these are my vertical asymptotes. Okay? If they would cancel, that would be a hole, and we'll see that in the next one. But for this one, we're just dealing with vertical asymptotes. So that means we have to set each one equal to 0. Because what really causes these asymptotes is when you divide by 0. These vertical ones, at least. So here I have to say x minus 3 when that equals 0, and x plus 2 when that equals 0. Okay. Then from there, I say x has to be 3 and x has to be negative 2. And these are my vertical asymptotes. So just real quick, I'm not going to graph the entire function, but if I had this right here, at negative 2, 1, 2, I'd have a vertical asymptote. And at 1, 2, 3, I'd have a vertical asymptote. So this could actually do things like come in here and dip down. We don't know if it hits anything, crosses anything. So, but when what happens in the middle is not important here. What happens on the outside? So when it approaches this dotted line, it will snug. It will fit into it. It will snug against it. It'll never technically touch it, but it will get really, really close. And then you could have things like this, and they just approach these asymptotes. So here, it could go down like that or up. Just really, it's the idea that it can approach. Alright, it can approach. So here, that's for that equation. So we'd say the vertical asymptotes are x equals 3 and x equals negative 2. Just remember that you need the x equals. It is an equation. It is a line, technically. Now here, if we say we have a new equation and we have f of x equals x squared plus 5x plus 4, and this is over x plus 4, then what I really need to do is I need to factor top and bottom. The bottom's already factored, but the top can factor. It can be x, and then we have plus 1 and plus 4. And then that's over x plus 4. Because these are the same, you can cancel out these factors. Okay, so really this equation is x plus 1. However, you'd be wrong to say the original equation was x plus 1, or else we would have written it like that. What we say is x plus 4 is what we canceled out. That when that equals 0, we still have a problem. I subtract 4, I get x equals negative 4. Okay? So that means, comma, x cannot be negative 4. Okay? And that's how I'd actually draw that. Now on a graph, because this is x plus 1 originally, it'll just be like the line x plus 1, so it looks something like that. Okay. Now here, x cannot be negative 4. Okay. Well, if we shift this over a little bit, shift the camera a little bit. If x cannot be negative 4, I come out here to 1, 2, 3, 4. Right here, I actually had to put an open circle. We call that a hole. So normally this simplifies down perfectly to this line, except when x is negative 4, because the original couldn't have a negative 4. This one can't either. It's the same graph. So we put a hole in there. So it just can't be there. And then as soon as it picks up on the other side of negative 4 on the x-axis, you start again. Same thing for left and right of negative 4. It can get infinitesimally close. It can get as small as you can imagine. But that is holes in vertical asymptotes in a nutshell. If you have any questions, email me, and you can find that on my website. Thank you.